Welcome to Rogers Math. My name is Jesse Rogers, and this is the solution for Power of Thor Episode 1. So this is a Codingame challenge. Difficulty rank is easy, and the community success rate is 62%. So not super easy, but this is suitable for beginners. So what you're going to learn in this puzzle is to compare different values. It says you have to correlate character variables and integer variables. A straightforward solution uses 8 conditions. There is a way to simplify it and use only 4 conditions. So I'm going to show you how to do both. And so we're going to go ahead and solve this. And I think I reset it. Yeah, so I reset it here. So this is as you should see it on your screen when you first load this up. You have some import statements. You have your variable assignments. There's a game loop, gives you remaining turns. Every turn it's going to update that, and it's going to expect an output. So that's sort of the minimal nuts and bolts of what's going on here. And there's a explanation of it that I'm going to go ahead and read down here. So you can fast forward this part if you've already worked on the puzzle, but if you haven't worked on this yet, let's go dive into it. So your program must allow Thor to reach the light of power. Thor moves on a map which is 40 wide by 18 high. Note that the coordinates x and y start at the top left. So this is not like the coordinate plane that you might have seen in algebra where it has negative numbers and positive numbers. These are starting at 0, 0 in the top left. That's how it's often oriented in games. And just like in the coordinate system, as you move to the right, the x values will be increasing. But unlike the normal math coordinate system, instead of negative numbers as you go down, these are actually going to be positive numbers the further you go down, because the top left is 0, 0. The bottom right is the maximum numbers. So that's going to be 39, 17 in our case. So once the program starts, you are given a variable light x. That's the x position of the light of power that Thor must reach. That's the goal. And then the light y is the y position of the light of power that Thor must reach. The variable initial tx is the starting x position of Thor, and the variable initial ty is the starting y position of Thor. Now, a quick word of annoyance maybe that, here, let me reset my code just to make sure. So if you notice with Codingame, this is one of the only things I don't like about Codingame, and I can fix it in 2 seconds just by telling you about this. So light x, you can see here, this is in what's called camel case, right? Where you've got no underscores, you've just got a lowercase starting letter, and you've got an uppercase letter for the next word or phrase or whatever it is. So light x is all one word, no hyphen, right? No underscore. Meanwhile, over here, when you actually get to the code, you're going to have light x, but it's in snake case, which is where it's all lowercase. There's an underscore, and then there's an x. So there's a misalignment between the light x here as a variable and the light x here as a variable. These are not written the same. And it's very important in a program that everything is written the same so that you don't have any so the computer is not going to know if you write it as light x, it's not going to recognize light underscore x and vice versa. So you have to make sure that your variable names are in alignment, and that is not the case in their auto-generated code. So that is kind of annoying for beginners, and I do just want to alert you to that. Because that gave me a lot of grief. It almost made me want to just quit the platform initially. When I first started this, it was so frustrating. But once I figured that out, everything else got a lot easier. So at the end of a game turn, you must output the direction in which you want Thor to go among north, northeast, east, southeast, and so on. So each movement makes Thor move one cell in the chosen direction. So southwest would move, for example, south, which means that you're increasing the y value, and west, which means that you're decreasing the x value. So he would increase the y value by 1, decrease the x value by 1 if he's moving southwest southwest. All right, so these just sort of give some scenarios right here. So let's say that the initialization starts Thor at the position 3, 6, and the light is at the position 3, 8. So the Y value for the light is greater than Thor's, and so he needs to move south in order to increase the Y values so that he finally arrives at round 2 at the light. So that's how that would work. All right, so do not forget to execute the tests from the test cases panel. That's over here. These are the test cases. Beware that the tests given and the validators used to compute the score are slightly different in order to avoid hard-coded solutions. So no worries, we're not going to hard-code our solution. This will be a general solution. All right, so game input. The program must read the initialization data from the standard input, then an infinite loop. In an infinite loop provides the standard output for the instructions to move Thor. You're going to get initialized with 4 variables: light x, light y, initial tx, initial ty, indicating the positions of the light. Initial tx and initial ty are the initial positions of Thor. Okay, so the input for a game round, it's only going to tell us the remaining turns. That's the only piece of information that it's going to give us per game round. And it's going to expect us to give a single line, a single print statement that moves Thor in one of these 8 directions. And there are some constraints for the board, right? It only goes from 0 to 40 for the X values and 0 to 18 for the Y values. And we have to have I don't know exactly how long that is. It's hard to gauge, but that's much less than a second response time for game rounds. But don't worry, the computer is pretty fast. It'll solve that in no time. Okay, so let's go ahead and first change these variable names. I don't necessarily want to have that in the snake case. I think I just want to call light X and light Y X and Y. Those are my target, X and Y. And then I'll call this Thor X, and I'll call this Thor Y, just to sort of distinguish those a little bit. And let's go ahead now and make a couple of, I'm going to get rid of all that. I don't need that. And actually, I don't need, so all those comment lines sort of kind of clutter it up and make it a little bit more confusing for me, actually. And I don't need to import any of the math or sys. So I'm going to go ahead and get rid of those two. I don't need to import them. So this is really the only thing that we're going to be looking at. So it's just going to be X, Y, Thor, Y, and our game loop. So what we're going to do is put in some conditional statements. So we've got remaining turns that we have to read, and then we're going to say if. So what are our situations? So if X is less than Y and X is less than Thor X, we want to compare apples to apples, right? So X is and Y is less than Thor Y. So let's think about what situation that would be. So if the X value, if our target is less than Thor X, then we want to move him west, right? And if the Y is less than the Thor Y, then we want to move him north. So we're going to print northwest. All right, so that would be that situation. And I'm also going to have to update Thor's new position, right? So that's one of the things that we're going to have to do with this in order to make sure that we're staying in alignment with what's actually going on in the game. So Thor X has to be updated. Northwest means that we're going to be subtracting 1 from the X for the west, and we could put a semicolon and we can write it on the same line to deal with the Thor Y, and subtract 1 from the Y as well. Now you'll notice that I put minus equals. So what that minus equals means, this is Thor x, let me write that another way, is equal to Thor x minus 1. So this is another way of, that should be capitalized, this is another way of writing that same statement. So this statement right here means the same thing as this statement right here. It's just a more concise way of expressing it. Basically, I'm taking whatever the value was and I'm just subtracting 1 from it. That's what that minus equals means. Okay, so I'm going to get rid of that. And by the way, if it's 1 equal sign, then what that means is that we are assigning something. And if there's 2 equal signs, if it's equals, that means we're asking the computer the question, is this equal to that? So it's a comparison. So these are both assignments. We're changing the value of the x and we're changing the value of the y to update it with the fact that we had to move west and we had to move north. So that's one of the situations. There's going to be 8 of these. So I'm going to put elif. And let's do another situation. So if x is less than Thor x and y is, now let's do the other direction. So that's going to be greater than Thor y. So what would happen in that situation? So the x is still going to be less than Thor x. So we're still going to move west. All right, so we're going to print, it's going to have a west in it. So we're going to be headed west. But first, we want to have either north or south. So our last one was northwest. This one's going to be southwest. But how do I know that? Well, the y is greater than Thor's y. So we need to increase the y values. And we increase the y values by telling him to go south. So this is going to be southwest. So now we need to handle our updates. So Thor x, we're still going to be moving west, so that means we're still subtracting 1. And Thor y is going to be updated with a plus equals 1, because now we're increasing the y value by moving him south, right? Because south will be on our game coordinate system. South is increased. And so that would be the way to go. All right, so now we're going to do another elif statement. Elif. And let's handle it the other way now. So x is greater than Thor x and y is less than Thor y. And you can see that this gets pretty repetitive, right? So I'm just going to go ahead and copy these. Copy this statement here. Let's save ourselves some time. So we're going to copy 1, 2, 3, 4, 5, 6. Let's see how many we got here. So the if to initialize it. So 1, 2, 3, 4, 5, 6, 7. I think we're going to probably end up needing 8. So let's see, we've got northwest, southwest. We're going to want this one to be, I think it probably would be easier to just organize it like this, where we're going to do now northeast and southeast, and then just north, south, east, west. And that's all the directions that we're going to need to print out. And then let's handle each of the situations where we would be doing that. So we're going to do north. We already handled northwest and southwest. Now let's handle the northeast. So when would we be going northeast? That would be if we want it to go northeast. That would be if, so Thor is going to be down here and light X and Y are going to be over here. So we need the y values to decrease because he's going to go north and he's going to go east. So we need the x values to increase. So x should be plus equals 1 and y should be minus equals 1 because we're headed north, right? And you can sort of look back on your work and sort of check that a little bit. So I'm referring, this is northeast, right? So I can sort of use the northwest as a reference because what I did in Thor Y for northwest, the north was handled by subtracting 1, right? So I know that should be consistent here. And this should be, this Thor Y for southeast should be adding 1, so that's good. But the east is handled by adding 1, so I need to change the x. I need to add 1 to the x, right? Because as the x values increase, we're going east. Okay, so that's lined up now for southeast. But I don't think I'm doing this a little bit haphazardly. I'm sorry. I'm sort of getting the pluses and minuses all worked out, but I don't think I did the conditions yet. So let's make sure this works. So elif x is less than Thor x and y is greater than Thor y. So is that what would make me go northeast? Well, let's see. So northeast, that we're going to do that if the x is, if Thor's x is less than the light x. So this is actually backwards because Thor's x would be the small one if we're going to be going east. So these x's that have east should be aimed that way, and these y's, if it's going to be a north, then you can look at the y here for a reference. North, what that looks like is that y is less than Thor y. So y is less than Thor y is what we should have for norths. And for souths, the y should be greater than Thor y, right? So that looks true. Okay, so I think we're good with the first 4. And now these are just going to be if y is, so you remember north was y is less than Thor y. That's going to make us go north. So y is less than Thor y, print north. And so I'm going to get rid of these x changes. So that's going to be heading north. And when we're heading north, remember that we're subtracting 1. That was when we were subtracting 1. And then south, that's where we're going to be adding 1. So this looks good. And this only should have a y, not an x. So we're looking at the y values. What would make us go south is if our target was greater than Thor's y. So that means we're going to have to add more values to get us to go south. So that looks good. All right. And then now we just have our east and west. So those are going to be x values, not y values. So I'm going to get rid of those y values. Change this to the y values. All right, so if x is less than Thor x, print east. So let's see, east. I want it to go east. So that actually looks backwards because I would want to do that. I would want to go east if the x value, which is my target, was greater than Thor x, then I'm going to have to head east, right? So that looks right. And I can refer back up here again. So northeast, that was if x is greater than Thor x. So x greater than Thor x, good. And then x less than Thor x, that is west. And when I go west, I am subtracting 1. So east, forgot to put the plus. Okay, so that was a lot to keep track of. We had 8 different conditions, and those are all those print statements that would generate those. So let's see if that works. I'm going to play all test cases. And okay, they're all turning green. So that is one solution to this. So that is one way to do it. That was a lot to go through, but you could see that it was a little bit easier when I copied and pasted it and then just did the corrections, because it's kind of a little bit easier for me to spot the mistakes in the code than it is to just write them all fresh. But you know, each person is a little bit different. So again, this did take a little bit of a while for me to figure this out and to implement it. So it's not just a matter of coming up with the idea, it's also the execution of it that definitely takes some time. All right, so that was solved there. Now let's try another way of doing it. So I'm going to go ahead and restore the default code, wipe away everything I just did, and now we're back to square one. So what I'm going to do in this one, I'm still going to get rid of all this stuff. I don't need it. It kind of distracts me. And I'm still going to change this to X, Y. I want to change these names because I don't always like the initial names that they give. Thor X and Thor Y. Okay, so and I'm going to get rid of this. Okay, so now I'm going to show you another approach to this, where what we're going to do is only use 4 lines, because what we're going to do is use we're going to initialize a new string, and this is going to be command. So command equals, and then I'm going to leave it as just a blank space. So we're going to give Thor some command, and that command is going to be determined by what the comparison is between his position and the light position. So this is going to be basically taking those same kinds of conditionals. So if we're going to start some conditionals where if X is greater than Thor X. Actually, no. You know what we want to do is we want to start with the Y's. And the reason why we want to start with the Y's is because it expects a north-south for each of these. So we're going to have our choice of either north, northeast, east, southeast, south, southwest, west, or northwest. But notice that north and south always come first whenever we're giving those angular directions where it's going at an angle. So I want to give the north or south first. So that means if Y is greater than Thor Y. So in other words, if Thor is down here and the target is up here, what do I want him to do? I want him to go north. So this is going to be print north, but I'm not going to do print north. I'm going to do command plus equals north. So I'm not going to immediately print north. What I'm going to do is just add it to the string that I'm creating here. So there's a north that's going to be added if command or if the Y is above. So I still need to adjust Thor's position. So Thor Y will again be subtracted. All right, so this will be minus equals 1, because when we're going north, we're taking away from Y. Okay, and then elif Y is less than Thor Y, so it's the other way around. Command, in this case, will be, I'm going to add a string that's going to be south instead of north. And then Thor Y, I'll have to add 1 instead of subtract 1. So that handles the north and south for the Y. Now I'm going to handle the north and south for the X. So this is going to be if X is greater than Thor X, then command would be plus equals. So if x is over here as a greater value than Thor x, then I want him to go east, right? So east, and remember that Thor x plus equals 1 is what happens when you're going east. And then the other way around, elif, I'm just going to copy and paste all this. Copy and paste. Okay, so elif, and it's just going to be the other way around. So elif, and this will be less than. And instead of east, this is going to go west, and this is going to be a minus. So I'm just switching those around. And then the last thing I'm going to do, I'm just going to have one print statement. So this is actually a little more concise. That's a lot more concise. I'm going to have one print statement, and it's going to be command. And let's see if this would work. Uh-oh. Okay, we'll come back to that one. Yeah, no, it looks like I got a mistake here somewhere. I forgot to change one of the directions or change one of the updates. So let's see here. So if y is greater than Thor y, then the command is, so if y is greater than Thor y, we do need to go north, and Thor y we would have to subtract 1. So what's he doing? What's his behavior here? He says he's going down. So if y is less than Thor y, command plus equals south. Thor y plus equals 1. And I think I maybe have these backwards, so let's just switch those around. Okay, yeah, I had those backwards. Sorry about that. So that is the other way to solve this, is to create a new variable that is a string and basically update that string with our information about whether we need to go north or south, or we need to go east or west. It's only going to add a north if a north is needed. It's only going to add an east or a west if those are needed. Otherwise, it'll omit those. And so that is pretty much the way that I solved this. Now you can go back. So I'm going to go ahead and play all test cases again, just double check. I think we're good to go with that. I'm going to submit. All right, and yes, I do know conditions, so I'm going to unlock that. And okay, back to home. So now I'm going to go back to the power of Thor, and I'm going to look at solutions. So once you turn in a solution, you're able to see other people's solutions. And you can see that there are other people who use something pretty similar to what I did. He's using, instead of command, he's using res. I don't know what that stands for, but he's doing something very similar to what I just did. And that was a solution by Aun, I guess. And then this was kind of interesting. This was another way of representing what I had done pretty much, where he's doing north or south depending on whether depending on which one was greater, and then he updates based on which of these north, south, east, and west are in your final statement, your move statement, and then he prints the move statement. So he does these updates in these 4 lines over here. I'm going to just kind of very briefly, I'm not going to spend a lot of time on it. I'm going to show you well, first of all, there's a competition that's starting in 12 hours, the Fall Challenge 2022. I'm pretty excited about that. I'm definitely going to be talking about that, so stay tuned. But I wanted to go through Code Golf of Power of Thor. So Code Golf is where you're trying to write the shortest code possible, and I came in 7,724th out of 37,000 people with a code size of only 168 characters. So this, what we just did, is condensed here and abstracted into single variables. It's pretty much unreadable unless you know already what the solution is and how to solve it. And if you're trying to think your way through it, it's definitely easier to give names to things that make sense. But this is the same process, just with the shortest code possible. And you can see the indents. Indents are required in Python. You have to make sure that you're indenting, but you can indent just a single character. So that's what I did in this case. And so it is possible to write that same code, just much, much smaller. And that's one of the competitive styles that you will also see in Codingame. So that can be pretty fun as well. I'm pretty sure these all work. Yeah. I didn't test this for a while, but I didn't change it either, so it should be good. All right. Well, that's pretty much it for this episode. And again, like I said, stay tuned. I've got some more videos coming that are going to be the other puzzles that are similar to the Power of Thor in difficulty. And then we've also got some AI bot matches that are coming up. Like I said, the Fall 22 challenge, that should be pretty exciting. So basically you're going to pit your AI bot against someone else's AI bot. Thousands of players are going to be on there, all trying to get their AI to beat your AI. And top 20 people are going to get t-shirts. So pretty exciting stuff. And I will see you in the next episode. Don't forget to like and subscribe.